Question number 2 taken from October 2002 Advanced Level Maths HSC S2. 1.5% of the population of the UK can be classified as very tall. First part, the random variable x denotes the number of people in a sample of n people who are classified as very tall. Given that ex is equal to 2.55, find n. For the second part, by using the Poisson distribution as an approximation to a binomial distribution, calculate an approximate value for that, an approximate value for the probability that a sample size of 210 will contain fewer than 3 people who are classified as very tall. Okay, so what do we have? We have the expectation of x, ex, being 2.55. And also, we should remember that the expectation of x is normally n, the sample size, multiplied by the probability of success. And over here, the probability of success p has been given in the question as 1.5%. We need to find the sample n, the size of sample n. Okay, so what do we have? Then ex, which is 2.55, this is going to be 2.55 is equal to n times 1.5%. In other words, we're saying n is equal to 2.55 divided by 1.5%. Work that out in your calculator, you'll end up with 170. So that's the sample size for the first part of the question, which is now done. For the second part, we are told that we should use the Poisson distribution as an approximation to a binomial distribution. Now, what is the Poisson distribution? We can say x follows a Poisson distribution with mean lambda. And if we have to find the probability of x is equal to, let us say, r, then we should remember that this is going to be equal to e to the power of minus lambda times lambda to the power of r, all divided by the factorial of r. So that's the formula we're going to be using throughout the second part of this question. The sample size is n is equal to 210, and we need to find the probability that x is going to be less than 3. Now, we should find the mean, and again we should know that the mean, which is the mean lambda, is ex, and ex is equal to np. So therefore I'm going to say n is going to be 210 times p, which is 1.5%. So let's just say 210 times 1.5 divided by 100, 3.15. So that means that the average or the mean is 3.15. So how are we going to do this now? Sorry. Well, the probability that x is going to be less than 3 is either going to be the probability of x is equal to 0, or x is equal to 1, or x is equal to 2. All these numbers here are less than 3. So therefore let's calculate the probability one by one. So p of x is equal to 0. Well, that's going to give us e to the power of minus 3.15, which is the mean, times lambda to the power of r, and lambda is 3.15, r is 0, over factorial of 0, that's going to give us e to the power of minus 3.15. Then the probability of x is going to be equal to 1, is going to be e to the power minus 3.15 times 3.15 to the power of 1, all divided by factorial of 1. And that's going to be e to the power of minus 3.15, okay, and times 3.15 to the power of 1 divided by 1, 0.134 something, okay, so 0.134984, 0.134984, and goes on forever. And for this one I got to the power of minus 3.15. It's going to give us 0.042852, and so on. Now, the probability that x is going to be equal to 2 is going to be e to the power of minus 3.15 times 3.15 to the power of 2, all divided by the factorial of 2. And for this one, again, your calculator is going to work handy here. E to the power of negative 3.15 times 3.15 to the square divided by 2 factorial 0.2226 and so on. So 0.2226 0.2126 and so on. Now we just need to add all these probabilities. So plus 0.134984, okay, plus 0.042852, 0.390. So this is your answer. Therefore, the probability that x is going to be less than 3, that is fewer than 3 people who are classified as very tall, is going to be, as we just found, 0.390 to 3 significant figures. And here we are for this part. Okay, that's it.